In this chapter on algebra, we move away from straight line or linear algebra, and we start to look at both the equation for non-linear, we look at the table of values, and we look at the graph of non-linear. The big feature, because linear means straight, the feature of non-linear means that the graph will be not a straight line. So we're going to see graphs that you might have already come across these, but graphs that are shaped like this, and some of you will know that that is a parabola, or it can be upside down, still a parabola. Some of you will be familiar with that graph. It's clearly not straight, and that one's a cubic. Some of you will be familiar also with a graph, if this is our x and this is our y-axis, of a graph that sits in there and runs along the axis, and then this one goes away to infinity, and there's a totally separate branch and it sits down there, and that's called a hyperbola. And some of you would also know that there's a graph that if this is the x-axis, this is the y-axis, the graph goes like that, and that's called exponential. So you might have come across these different shaped graphs before. It's going to be important now that you can put a name to the graph and its features. So we'll look at the equation, we'll look at a table of values, and we will look at the then graph, just like we did for a straight line. We looked at the equation of a straight line, the table of values for a straight line, and then the graph of a straight line. So the first one we'll look at is the quadratic. Now, please become familiar with that word, quadratic. You will hear me use it, and if I'm using a term that means nothing to you, then you're losing some valuable instruction or information. It's really important that any term I use, that if you don't understand it, then you will jot that down. If you're watching a video, jot that word down, or if it's in class, you'll put your hand up and ask me what that term actually means. Because if you don't understand it, then you'll have a gap in your understanding of what I'm saying, and you're not very likely to remember it. Anything I'm telling you that you don't understand, you probably won't be able to remember. So functions or equations, so you'll hear me use this term function now. Think, every time I say function, think equation. So equations involving higher powers or indices of x, such as x squared or x cubed, are called non-linear, not straight functions, because their graphs are not straight lines. When we come to graph an equation which has an x squared or an x cubed in it, then it doesn't produce a straight line, but they are what we refer to as curves. A function in which the highest power or index of the x is a 2 is called a quadratic, and hence the name of this exercise. Now, remember that when we were doing straight line, we learnt straight line. Equation of a straight line is in the form y equals mx plus b, or ax plus by plus c is equal to naught. Two forms for the equation of a straight line. Now we have to know the general form. Quadratic is y is equal to ax squared plus bx plus c. So we have two x terms. You don't have to have the second x term all the time. The important thing to have is the x squared. And the a, b and c are numerals. That just means they're ordinary numbers. They could be decimals, they could be fractions. So they're just numbers sitting in those spots. So this is equivalent to the ax plus by plus c equals 0 equation for a straight line. Some examples would be, the simplest example is y is equal to x squared. Remember I said it wasn't necessary to have the x and the constant? So that's the simplest form of a quadratic equation, and that was meant to be a nice x. You could have y equals x squared plus 2x. You could have y is equal to x squared minus 5. You could have y equals x squared minus 2x minus 1. Or you could have y is equal to negative x squared. There's an infinite number of examples of quadratic equations or functions. So we know that when we graph, we know it already, that it's going to form this U shape, and it's called a parabola. So again, become familiar with that word because you'll hear me say it, and if what I'm saying you're not registering what I'm referring to, then like I said before, you're hardly likely to remember what I've just said because you don't really understand it, and therein will be a problem. Most of the things I'm saying, it's important for you to be able to remember. We start by looking at, like I said up here, that the simplest quadratic is y is equal to x squared with just a 1 at the front. And I can put that in here. Y is equal to x squared, and its graph looks exactly like that. It's a nice parabola. So it's this parabola shape. It has the bottom, it's not called the bottom, but it's called a minimum. That means that's as low as the y values ever get, then the y values go back up. It's also called the vertex, and its vertex is at 0, 0. That makes it quite a special quadratic, in that it won't have any x term. It'll have an x squared term, but no x term and no constant. Remember I'd said we will look at the equation, we'll look at the graph, and we'll also look at the table of values. So if we were just following from the equation, y is equal to x squared, and I put minus 3, we know that y is equal to negative 3 squared. Well, the negative times a negative is a positive. Squaring a number always makes it positive, and 3 3s are 9. So at negative 3, was there a point plotted at 9? Yes, here and here. That's negative 3 for x and 9 for y. At negative 2, negative times a negative is a positive. Square anything, it's definitely positive. 2 2s are 4. 1 goes to 1. 0 goes to 0. And here it is, just confirming that the vertex, or the minimum, occurs at 0, 0. There it is, 0 for x, 0 for y. Back to filling out the rest of the points. At 1, is y 1? Yes, it is. On the graph, at x is 1, y is 1, is a point on the graph. And at 2, we go to 4, and you can see that occurring as well. From 2 up to the graph, yes, it's a bit wonky, but it goes across there to 4. and at 3 it goes to 9. It's nice and symmetrical. We call that symmetrical. The graph of y equals ax squared is a parabola, just reinforcing these terms, or U-shaped curve. The graph of minus ax squared is an upside down. So the graph, we're not doing a negative one yet. I'm going to stop the video there because it's getting a bit long now. I'll fill out these tables of values and graph them and come back and talk about it.